So this is the SAT practice test 1, the math section, section 4, which allows the use of a calculator, but I'm going to try to go through this without a calculator. We're going to go through questions 26 through 30. Question 26 reads, Katrina is a botanist studying the production of pears by two types of pear trees. She noticed that type A trees, produce 20% more pears than type B. So type A trees produce type B plus 20% more. Okay. Based on Katrina's observation, if the type A trees produce 144 pears, how many pears did type B trees produce? Okay, so type A, let's do this. So type A is going to be 120% of type B. Okay, so this is going to be A is 1.2 B. Now we're told that type A produced 144 pears. We want to find out how many type B produced. So we're going to divide both sides by 1.2 to get the number of pears that type B produced. So we have 144 divided by 1.2. We're going to multiply both top and bottom by 10 to remove the decimal. So we have 1440 divided by 12, and this is going to give us 120. So type B produced 120 pears. Number 27, a square field measured 10 meters by 10 meters. 10 students each marked off a randomly selected region of the field. Each region is square and has a side length of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 meters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So we have 10 regions here. Well, if we start off with the field measures 10 by 10, so we have an area of 100 square meters. Each region measures 1 by 1, so that is going to give us 1 square meter per region. So this already lets us know there are about 100 regions. Now we're given the number of earthworms for 10 of these regions. So if we add the number of earthworms in all 10 regions, we end up with approximately 1,500 for 10 regions. And we want to find out how that applies, how to approximate for the whole field. The whole field has 100 regions, so we multiply number of regions by 10, number of earthworms by 10, so we have about 15,000 earthworms in the whole field. If the system of inequalities y greater than 2x plus 1 and y greater than 1/2 x minus 1 is graphed in the plane above, which quadrant contains no solution to the system? So let's start with y greater than 2x plus 1. So let's assume this is the y-intercept. This is going to be the x-intercept. So let's look at the graph is going to look something like that. So let's try the origin, 0, 0. So 0 greater than 0 plus 1. So that is not true. So this is going to be the region for that graph. Now the second inequality graph that we need to look at is 1/2 x minus 1. I'm going to use a different color just so we can see the difference. Okay, so 1/2 x minus 1, we have minus 1 over here, and this is the intercept. And so try the origin again. 0 is greater than 0 minus 1, so 0 is greater than minus 1, so anything with the origin is an acceptable. So as we can see, there are points in all 4 quadrants. So there are points in all 4 quadrants for these inequalities if you take them separately, but if you take them as a system, it means that for them to be part of a system, it means that all the quadrants must represent both inequalities. So if you look at the first one, it's shown in quadrants. You have points in quadrant 1, 2, and 3, but no point in quadrant 4. But for the second one, you have points in quadrant 1, 2, 3, and 4. So you have to have an intersection, and you can see here that because it's a system, quadrant 4 does not represent the system. And the reason why that is because the first inequality, which is y greater than equal to 2x, so it should be solid lines actually. For the first one, it should be solid lines all the way through. So y greater than equal to. So because that does not have any points in the fourth quadrant, that means the system cannot have points in the fourth quadrant. Number 29, for a polynomial p of x, the value of p of 3 is equal to -2. Which of the following must be true of p of x? So if p of 3 equal to -2, what this means is that p of x divided by x minus 3 is going to give us q of x with a remainder of -2 over x minus 3. That's what this means. This is the remainder theorem. If there was no remainder, p of 3 will give you 0. This is to show that it's a factor. But now that we have a value of -2, this represents the remainder after the division. Number 30, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinate of vertex A can be identified as constants in the equation? Now let's look for the coordinates of vertex A. The coordinates are going to be 1 and -16. So what we're going to look for, we're going to look for an answer that looks in this format. Let's call it ax minus 1 squared minus 16. Because when you complete the square of whatever the equation is that is drawn here for this graph, the equation for whose graph is drawn here, and you have a vertex at this point, it means a could be any number. So you have x minus 1 squared. This is the x value of the vertex, and this is the y value of the vertex. So this is what we have for the answer.